Hello there. Welcome to the video lectures of strength of materials. In this video lecture, we are trying to understand the different parameters like the longitudinal strain or linear strain, the lateral strain, and the Poissons ratio. As we know, these parameters are widely using to find out the change in dimensions of the component. Like the strain components we are going to be calculating, right? So to explain this one, we are going to be taking one example over here. That's going to be a bar I have taken, which is going to be cross section is going to be in the rectangle shape, right? Or the square shape or circular shape, whatever the shape if you want, you can consider. There we can see the bar member is going to be consist of the L. L is going to be the length of the member, and it is going to be subjected to the, intentionally we made to subject it to the load, that's going to be the P, right? That's going to be acting axially. That means they are acting in the neutral axis. So, and it is going to be the tensile forces. And then what will happen? As we know that any material is going to be subjected to the external force, then it starts to deform up to certain limit, right? So within that limit, it trying to perform its own the given function. After that, it starts to fail. Now the condition is that we are assuming the load is going to be applied axially. Then what happened? In the length direction we applied, then automatically the member started to elongating. That means the material existed in the transverse direction, it started distributing in the longitudinal direction. So there we can see here, the length is going to be, the initial length of the member is going to be L. But when it comes to the final length, that's going to be L plus del L is going to be available. There we can see the load is going to be still acting. There I have shown here is the dotted lines. That's going to be the existed. That means the precondition of that material, and then it started elongating. The same thing we can see over here in the side view also. So this dotted lines is going to be representing the original cross section of the member. That's B is going to be the breadth, and D is going to be the depth of that member or height of the member we are going to be calling. And after the elongation, then what happened? The height, that means the depth will going to be changes to D minus del D, and the width is going to be changes to B minus del B. So here, so these kind of the phenomena we are going to be observing in our daily life also. Then we need to find out certain parameters to describe these conditions. So that's first one is going to be the longitudinal strain. What is the longitudinal strain or linear strain? That's going to be the length is going to be existed. That means the load applied along the length of the member. So then R, the load is going to be acting in that direction. We have to be considered that is going to be the longitudinal or the linear strain. Either the length of the member we have to consider, the first condition. The second condition, suppose the load is going to be acting in this direction. That means that direction we have to be considered longitudinal. But suppose the load is going to be acting, in this case is going to be transverse. That side I am going to be considered the longitudinal, and this side is going to be the lateral conditions. I hope you are able to understand over here. So then what is the definition of the longitudinal strain? As we know, the strain is nothing but the change in dimension to the original dimension. Now we are specifically going with the longitudinal strain. So that the longitudinal strain LS is equal to, what is the formula? Change in dimensions in the longitudinal direction to the original length. So that means change in length to original length. So in this case, what is the change in length is means in this case how much we are getting? That's going to be change in length is going to be del L. The change in length we are getting the final length minus original length divided by original length we are going to be taking. What is the change in length here? That's going to be L plus del L is going to be your change in length divided by L we are going to be considering. That means L plus del L minus L we are going to be considering. So if once I am going to be developing this mathematical model, then finally I am going to be getting del L by L. So this is going to be the longitudinal strain. Right? Now we are going to be trying to find out the lateral strain. As we know, the dimensions in the direction of the depth and the breadth, so that it started to shrinking, because we are assuming that in this direction tensile force is going to be acting, in this direction there is a compressive force is going to be acting. Now we can see that's going to be the lateral strain. The same definitions we are going to be taking the lateral strain, that's going to be change in length, change in dimensions in the lateral direction to the original dimensions. Suppose in this case I am going to be considering the lateral or transverse direction. the lateral strain is equal to change in dimensions by original dimensions. So in this case what will happen, there is a two types of lateral strains are there. One is going to be in terms of the depth, second one is in terms of the breadth, because these two dimensions are perpendicular to the applied load. So then what is the equations we are going to be getting? That's going to be del B by B or del D by D we are going to be getting. So this is called the lateral strain. The lateral strain is always, it is perpendicular to the applied load directions we need to be considered. So the finally lateral strain is equal to del B by B or del D by D. That depends on the direction of that we have to be considered. Now we are going to be discussing about the Poissons ratio. So here is the Poissons ratio. So then what happened here? The longitudinal and the lateral strains, they are looking individually. But actually only the load is going to be acting in only the one direction. But in other directions, dimensions are going to be started to diminishing. So then we need to find out the relationship between the longitudinal and the lateral strain. So then this is the Poissons ratio where it's going to be fulfill the gap between these two, or it will make the relationship between the longitudinal strain as well as the linear strain. So then the mu is going to be your indicated letter, or some people also they will write 1 by m also. So it depends on your usage, you can. So the Poissons ratio is equal to, that's I am going to be taking the lateral strain of the member divided by longitudinal strain. Longitudinal strain. So there we can see here. So the lateral strain by longitudinal. It is very clear that when the member is going to be applying the load in this direction, we will consider the strain is going to be the positive direction. But in other directions, the dimensions are going to be start to diminishing. That's we are going to be considering the negative direction. Suppose if I am going to be substituting in this equation, so the mu is equal to, what is the lateral strain here? That's going to be either width or breadth we are going to be considering. That's going to be del B by B divided by del L by L we are going to be taken. So we are going to be writing it another terminology. That's going to be, sorry, this is the B. So del D by D divided by del L by L. So this way we are going to be making the relationship. And in other case also we are going to be writing that the same with respect to the definition mu. So that's going to be, suppose if I want to find out the lateral strain, that's I'm going to be taking ET, that is going to be transverse directions we are getting, that is equal to minus of mu into longitudinal strain. So this I am going to be writing epsilon t minus mu into epsilon L. This way also we can define your Poissons ratio. So I hope you are able to understand that what is the longitudinal strain and what is the lateral strain, and how we are going to be making the relationship between these two is going to be the Poissons ratio. So the Poissons ratio, sometimes it's going to be positive, sometimes it will be the neutral, or maybe sometimes it's going to be the negative. So in this case what will happen, always we are going to be considering the positive. That reason that along the length of the load, that means along the direction of the load, the member is going to be start elongating. Suppose you can take the rubber or mild steel. These are going to be elongating in the direction of the applied load, any material. But when it comes to the cork material, so then what will happen, when you are applying the load, that cannot change its dimensions. That means the Poissons ratio we are going to be getting the zero conditions. So that means Poissons ratio will become 0 for the cork. Suppose when the material you are applying the load in this direction, but what will happen, this length will going to be start to shrinking, right? And then area will going to be in this direction, lateral directions are going to be increasing its dimensions. Then we can say that is going to be negative Poissons ratio. So those examples we have to be create intentionally with this. Suppose for this one I can tell. So here is the example for the negative Poissons ratio. So suppose if I am going to be considered here, this kind of the object intentionally I have prepared for the specific application. So then in this case the total length is going to be this one, right? This is going to be angle bracket I have taken. Then the load is going to be acting in this direction. That means axially I was applied, and it has the thickness. Can you see, once the load is going to be acting on this member, so then it started to move in this direction. So then what happened, these angles will going to be become the flat, and then automatically there is a restrictions are going to be creating. Suppose there is a opening of the walls and closing of the walls, these devices are going to be quite helpful. So then what happened here, the length will going to be decreases, that's going to be, can you see, L is equal to here L minus del L. But in this case what will happen, the thickness will going to be increases, the T plus del T. So this is going to be, the load is acting in this direction, but the dimensions are increasing in the transverse direction. So in these directions the dimensions are going to be increases. In the same direction the dimensions are going to be decreases. I hope you are able to understand what is the negative Poisson's ratio, right? So still if you feel any difficulty, just you can put in the comment section so that I can reach you. So thank you.